Beyond the Maillard reaction lies a hidden molecular war, where heat and oxygen transform ordinary sugar into extraordinary flavor through controlled molecular destruction. Forget everything you know about browning meat. Today, we strip away proteins and fats to witness a far stranger form of molecular transformation.
The Maillard reaction depends on proteins and sugars. Caramelization strips everything away, leaving carbohydrates alone to face extreme heat.
This isolation allows scientists to observe what sugars do when no other molecules interfere.
The experiment begins with a simple question. What happens when heat pushes sugar beyond its comfort zone?
Every degree adds energy. Every vibration weakens the molecular bonds holding sucrose together.
At approximately 160 degrees Celsius, the transformation begins. Sucrose molecules absorb enough energy to fracture their internal architecture. Order dissolves, instability emerges. What was once rigid and ordered now becomes fluid and unstable. The transformation is in progress.
This is the first breath of caramelization, the birth of liquid sugar chemistry.
Oxygen now enters the story, steering destruction away from simple burning and toward flavor creation.
Without oxygen, sugar simply chars, but when oxygen ignites the reaction, new chemistry emerges. Highly reactive oxo collides with fragmented, forming new bonds. This creates aromatic molecules like furans, aldehydes.
Now the reaction enters its most precious and unstable phase.
Among the products appears diacetyl, the molecule responsible for the rich buttery aroma of caramel.
This fleeting molecule creates the unmistakable scent that signals perfect caramel.
The caramelization process begins with minimal reaction. As heat rises, Maillard reactions develop complex flavors. Finally, high heat releases the fragrant gases of caramelization.
The sweet spot lasts only moments before chemistry pushes forward. The most desirable phase of caramelization may be the shortest-lived stage in the entire reaction. But heat never stops. The molecular battlefield grows increasingly hostile. Sweetness starts to disappear as sugar fragments into increasingly complex compounds. New organic acids emerge, reshaping flavor and altering aroma.
The buttery notes begin fading.
In their place arise furans, molecules associated with deeper, sharper, and sometimes medicinal aromas.
The chemistry is no longer building flavor. It is fighting collapse.
Every second now separates extraordinary flavor from irreversible destruction.
Large molecular structures shatter into smaller and increasingly unstable fragments. The visual darkening reflects profound molecular change. The system approaches the threshold where flavor gives way to carbon. Oxygen can no longer sustain the aromatic dance that once created sweetness. The chemistry begins losing complexity as destruction overtakes creation. The chemistry begins losing complexity as destruction overtakes creation. The final stage has arrived. Most recognizable sugar structures are gone. A difference of mere seconds separates culinary perfection from flavorless ash. Modern culinary science is the art of stopping destruction at precisely the right moment. The secret of caramelization is not avoiding molecular destruction, but controlling it. What tastes like sweetness is actually a brief victory over chaos, a delicate balance of heat, oxygen, and molecular collapse. The secret of caramelization is not preventing molecular destruction, but mastering it. Between crystal and carbon exists a narrow golden window where chemistry transforms collapse into flavor. Heat, caramel, create a brief victory over chaos. This is the science behind flavor. This is
Knowledge has the power to transform lives. At SKM Edutech, we bring education to life through powerful visuals, engaging storytelling, and innovative learning experiences. Subscribe today and become part of a community where curiosity meets excellence.